Welcome to the session of Electric and Hybrid Vehicles, Module 2. In this session, we'll be discussing about the efficiency analysis of IC engine vehicles and electric vehicles. So here we will see the efficiency analysis of the IC engine vehicles as well as electric vehicles. So we are going to check what is a well-to-wheel efficiency for a conventional vehicle as well as electric vehicles. A well-to-wheel efficiency means that from the source of the fuel, from there by the time it reaches or that is energy is used by the vehicle in the wheels, how much is the total efficiency. And this well-to-wheel efficiency can be split into well-to-tank efficiency, that is what is efficiency once it is transferred, this form of fuel is from its crude form, it is reaching the tank, what is the total efficiency, and tank to wheel efficiency, that is from the tank once we are getting the fuel from the tank, petrol pump or pump in the case of conventional vehicles, and from the charging station in the case of electric vehicles, what is the efficiency from this tank to wheel. So all these things will be discussed in this efficiency analysis of IC engine vehicles and electric vehicles. So taking first the efficiency analysis of electric vehicle, this power input to the EV can be considered from two sources, that is from the stored power sources as well as from the applied power sources. So stored power sources means that it is the power which is available during the process from a storage device like a battery or the power which is extracted from a piece of coal by burning. So all those things are called as a stored power, whereas the applied power means that it is actually which is indirectly the power obtained from the raw materials, like the power or the electricity generated from the crude oil and delivered to the electric car for battery charging. That is an example for indirectly, that is an example for the applied power. So this applied power is usually represented by P in row, that is from the raw material, and this P in process, it represents a stored power. So total input is equal to P in power plus the P in row. So you can see that this P in row from this crude oil it is coming, and P in process from the stored power sources, and this will be given to this EV process, and the output power is represented by P0. So now we will see what is this EV process, what is happening inside the EV process. So if you take the EV process, actually there are mainly 7 steps. You can see this refinery, that is raw to fuel oil. First it is converted, then the electricity generation, then the transmission and distribution, that will be going through the charger, charge and discharge process, then the power converter, electric motor, then the transmission through the axle. So all the stages you can see there will be power losses, and efficiency of each stage is represented by eta 1, eta 2, eta 3 till eta 7. Okay, so the total efficiency will be a product of all these efficiencies. So if you take the total efficiency of the EV process, you can see it as P naught by P in, or P output by P input, and you know this is P output by input can be written as output plus the losses. So we are having 7 stages, so the losses of 7 stages if you add will be getting, if you add that with the output power, will be getting the total efficiency, which is also a product of P eta 1 into eta 2 into eta 3 into eta 4 into eta 5 into eta 6 into eta 7. Similarly, if you take the efficiency analysis of an IC engine vehicle, here also you can take the input power from two sources, P in row and P in process, and this is IC engine vehicle process. So if you just check the IC engine vehicle process, here you can see the stages, that is the refinery, then distribution from the refineries to the gas stations, internal combustion engine, and then the power is transferred to the transmission axle. So here there are mainly 4 stages, so represented as efficiencies as eta 1 to eta 4, and also in the stages also there are a lot of losses. So finally the total efficiency will be the product of all this efficiency, eta 1 into eta 2 into eta 3 into eta 4. So this is a table which is obtained from Hussain, your main textbook. So it shows that these are the 4 stages in the IC engine vehicle, that is refinery, distribution engine, transmission axle. So the efficiencies, maximum possible efficiency and minimum efficiencies are shown. And for EV vehicle, these are the different stages: refinery, generation, transmission, charger, then the battery, motor controller, transition axle. The maximum values and the minimum values are shown. And finally, if you multiply these efficiencies, you'll be getting the minimum and maximum limit. You'll also be getting the minimum and the maximum efficiency. So you can see that, of course, this EV, electric vehicles, will be having a more efficiency. This is based on the previous results, and if you check, this is a figure which obtained from the net. So you can see that if you take 100% efficiency for this one and this one, this 100 into 33 into this 94, that is for generation and transmission. Once you multiply 100 with 33 and 94, you'll be getting approximately 31%. That is a well to tank efficiency for electric vehicle transmission is finally 31%. And if you check this efficiency, that is a well to tank efficiency for this conventional vehicle, it is almost 80%. See, it is a round figure. It will be different according to different studies, but approximately these are the percentages well to tank efficiency. But when you take the tank to well efficiency, it is 76% efficient in the case of electric vehicle, tank to wheel efficiency, but it is only 16% from this tank to wheel for a IC engine vehicle. We know that the efficiency of the engine is very less. So when you take this efficiency, it is very less. So finally you'll be getting about 23% and 13%, almost what we have got over here. So this will be the approximate efficiency, final efficiencies for IC engine vehicles and electric vehicles. But here you have to remember that here we have started from the crude oil for this electric vehicle. If you are having a better methods or a better process of a better electricity generation process, then of course this efficiency will be much better than the IC engine vehicles.